All right. Hello, class. This is Miss Chu. This is the first time that I've recorded a lesson for our class in particular. I have done some recordings for my bio classes, and so Grace and Drew, I'm sure you've seen those. But it is the first time for our class, so do leave a comment on the check-in post and just let me know, what you thought went well, and then what you maybe would like to see for next time. I really want your feedback on this stuff. But I did want to record this lesson because it is teaching a little bit of a math skill. It's very basic algebra, but I know sometimes people might want to go a little slower, or some of you may be more comfortable with it. So I did want to give you the option of learning this at your own pace rather than me talking it through during a live class. It should be pretty short, okay? It's pretty simple. We are kind of simplifying this topic because of, the situation that we're in, obviously. Normally I would go into a little bit more detail, but this is the basic stuff. And so you can see here on this title slide, it says making diluted solutions in the lab. And so this is something that you're going to be doing a lot if you're ever in a lab. If we were in school right now and we were working in the lab, we would be doing a lot of this so that we could get solutions that we could actually use in experiments. Okay, so I'll talk about what's going on with diluted solutions. And I did also mention this in our check-in, but this is something that you will need to know if you do move on to level 2, and so that's why we are still teaching it, even though it's not something that we're going to be able to put into practice right away. And so here's just some vocabulary, okay? And so when we're talking about diluting stuff, right, we're kind of watering it down, right? And so we have to understand, what's actually going on at the kind of particle level, right? And so we'll be using these terms, okay? And so the first one is solute, and you can see here it says it's the material that is dissolved in a solution. And so it's, I guess we could call it the minor part of the solution, right? It usually takes up less of the solution. Okay, and I'm sure you can think of a lot of different kind of everyday examples. And so some that I will offer to you are, for example, sugar, right? If you're making sugar water, or salt, right? Salt is something that we use as well in the lab for some things. So that would be sodium chloride, NaCl. That's salt. And so those would be examples of solutes. Okay, so they're dissolved in the solution. Now, the solvent is the larger part of the solution. I also like to think of it as what's being dissolved in. And so oftentimes this is going to just be water, but it can be other things. It could be, sometimes there's going to be different types of alcohol that are being used as solvents. But typically, yes, it's going to be water. Water is usually the most common and oftentimes the best solvent as well. Okay, this diagram is just showing diluting, right? So you get the dilution of color. So, for example, food dye. And this is showing, what might be happening at, again, the particle level, right? So in the more concentrated solution, there's more of these blue dye particles, okay? And if we dilute the solution with water, for example, then we will find that there's less frequency of those blue particles. And so just to also make sure that we all know, concentration in this sense is obviously not, if you're really focused on something, it's like how much, kind of how dense. We have talked about density before in this class, but this is specifically for solutions, for liquids. Okay, so that's some initial vocabulary for us. And we also sometimes call the solvent the diluent, okay, which comes from the word dilute, right? So it's what you're using to dilute. And so if you see that, then that's what it means. And here's an example again of this is sucrose, which is a type of sugar dissolved in water, right? So it is a sucrose solution. We have mentioned this notation before. I don't know if anyone remembers. This is 30% weight by volume, okay? And so, we have calculated those things before, but it's another way to measure concentration. All right, and so what we're going to be talking about today is concentration based on molarity. Okay, and so this is where I would have normally gone into more detail if we were, in school and meeting each other every day. Those of you who have taken chemistry, this may be familiar to you. Molarity refers to a unit of concentration, and it's referring specifically to the number of molecules that are in, a given amount of something. Okay, right? So as you know, everything is made up of atoms or molecules, okay? And so, there's going to be many, 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 many of them in any kind of given area that we can measure. And so a mole, okay, you can see there's this moles here. So 1 mole of something is just referring to like a certain specified amount of molecules. And so the analogy that I often use is like a dozen, okay? So a dozen refers to 12. So it's like a special word for 12, and everyone knows what it is. A mole is a special word for a very large number, actually, okay? And so it's a very large number, essentially, of molecules, okay? Because they're so small. And so molarity then, okay, is a unit of concentration specifically. And it's just talking about, well, how many moles, okay, so how many large numbers of solute, okay, so remember solute is what's dissolved, is dissolved in a liter of solvent, right? So the solvent is going to be, the water or whatever it is. Okay, and so here's our bottle, okay, of sodium chloride solution, right, salt. So we'll use this as an example to explain what I mean by molarity. Okay, so you can see here on the bottle, it says that there is, the concentration is 5M. Okay, so you would read this 5 molar. All right, so 5 molar NaCl. Okay, so you probably, probably looking at this like some kind of mysterious code. Okay, so we'll just break it down right now. 5 molar is referring to the concentration of this NaCl solution. Okay, and so it's talking about, well, in 1 liter of this bottle, so let's say this bottle has a liter. Okay, so a liter is a measurement of volume, right? In this bottle, we have a liter of this solution. And in that liter, there are 5 moles of NaCl, sodium chloride molecules that are dissolved in it. Okay, so if you think of the sodium chloride molecules as being these little dots, little dots of salt basically. Okay, there are 5 moles of them all dissolved in this 1 liter of, we're going to assume it's water. Okay, and again, moles is like a stand-in for this very large number. Okay, and so essentially that's what molarity is, right? It's just saying, well, for a whole liter of something, well, how many moles do you have? Okay, it's a measurement of kind of, again, like kind of like density, right? But we're talking specifically about liquid. Okay, and so why we use this is because it's a standardized way of referring to concentration, because the concentration of a solution is really important and it's going to affect your experiment a lot, right? So if you have this really strong, really concentrated solution, it's going to work differently than if you had something that's a lot more diluted. And so why this is often relevant to us specifically in the lab is because when we store solutions, like, you buy them from the Biotech online store. Everyone always asks me where you buy stuff. Well, it's from, they have online suppliers. So we'll buy our, sodium chloride solution from the online supplier, and it comes, again, right, in this bottle, and it's at a concentration of 5 molar. And that's actually quite concentrated. Okay, so that's basically saying, wow, in that liter of solution, there's a lot of salt in there. Okay, and a lot of times we don't want it to have that much salt when we're actually using it. The stock solution is our word for the bottle that you get from the supplier that you would keep like in the stock room, right? Think of like a store, like in the back closet, right? In our storage closet. That's where we keep it. And oftentimes it's this concentrated because if you think about it, the more concentrated it is, the less space it takes up, right? It's like more packed together. So it's better for storage, right? But it's not so good for when we're actually using it, right? So let's say we need it to, I don't know, to run a gel or something. We're doing gel electrophoresis. It's too strong, it's going to mess everything up. So we have to figure out how we can make it less concentrated. Okay, so we want to maybe say push the 5 molar concentration all the way down to 0.25. All right, so that's a quarter of a molar. That's a lot less concentrated. And so we need to find a way to do that, right? And we're going to have to use a little bit of math to do it. But that's why we would need to be doing all this stuff in the lab. All right, and so we have this handy dandy equation that we can use to be able to calculate this. Okay, so you can see here what's just popped up on the screen is the equation, and it says C1V1 is equal to C2V2. Okay, and here is what I mean by those variables. C1 is talking about the concentration of the original or stock solution, right? So 1 obviously is like what you're starting out with, right? C is for concentration. V1 is the volume of the stock solution, right? So the original volume that you're starting out with. And then, conversely, C2 is your final concentration. So in this case, our final concentration that we're kind of shooting for would be 0.25 molar. And then the volume, okay, of the final solution is represented with V2, right? V for volume. So essentially what this equation is saying is that what you start out with, if you multiply the concentration and the volume together, you should end up with the same as if you multiply the concentration and the volume together of the final, okay? So the C and the V of the 1 multiplied together is equal to the C and the V of the 2 multiplied together, okay? And so you have 4 variables here, okay? And so hopefully everyone has at least this level of algebra kind of under their belt, okay? We have 4 variables, and if we have at least 3 of those variables, then of course we can find out the 4th one, okay? And so typically what's going to happen in the lab is that you're going to have the concentration of the original solution, our C1. You'll have the concentration of the final solution, like what you're shooting for, which in this case is 0.25 m. And then you'll also have the volume of the final solution because like how much you want to make, right? Like, for the experiment, maybe you need to make 500 milliliters of the solution. So you usually have C1, you'll have C2, and you'll have V2. And so what you're going to want to figure out is V1. You're going to want to figure out how much stock solution should you use and then add water to in order to dilute it to your final solution. Okay? And so really what we need to get out of this is that we have this equation, okay? We have what all these variables stand for, and I want us to be able to solve these equations. So if I gave you 3 out of these 4 variables, you would be able to plug it in and you would be able to solve it, okay? And so again, this is going to require that you understand basic algebra, and I do have different methods for us to be able to solve it maybe in a bit of a simpler way. So I will be putting that in the assignment that you're going to be completing to practice this stuff, okay? But let's maybe just do this one problem here as a practice. And I'm going to try to move my recorder thing is kind of in the way here. Okay, so it says make 5 milliliters of 0.25 molar NaCl solution from a 1 molar stock solution. Okay, so I would pause the video right now, okay, and try to do this problem based on what I've said so far. Just give it, your best shot. Okay, and then I'm going to kind of walk us through it verbally, but pause now, okay, and then come back. All right, so hopefully you did pause, and then you're back now with your attempt at this problem. And so I do apologize. I really would have liked to kind of write on the screen for this, but I have yet to figure out a way to do that and record myself at the same time. I'm sure there is a way. I will figure it out for next time. But I will kind of verbally walk us through it, okay? But here we have, a bunch of numbers in the problem, and we want to pick out those variables, right? So we want C1, we want to find C1, we want to find V1, we want to find C2, and we want to find V2. Okay, so let's start with C1, right? Because I said in the last slide that C1, the original concentration, you're usually going to know it because it's going to be on the label of that stock bottle that you get, like I said, from the store. Okay, and so the original concentration, okay, is going to be this 1 molar stock solution, right? Remember, stock is like the original that you keep in the back. So we can write C1 is equal to 1 molar. Okay, so we've got one variable down. Now we need to find another one. So let's skip over V1, right? Because I said that usually the volume of the original is what you're trying to figure out. So let's see if we can find the concentration of the final, C2. So it says make 5 milliliters of 0.25 molar NaCl solution. So we want to make this solution, right? So that's going to be our final concentration. So our C2 is going to equal to this concentration here, 0.25 molar, okay? And then it says make 5 milliliters, right? So that's what we're shooting for. We want to end up with 5 milliliters of this diluted solution. So our V2, which is our final volume, is going to be 5 milliliters, okay? And make sure that when you're solving these problems that you write the units next to all of your numbers, or else you are going to get confused, okay? So always write your units, okay? So I've written down here on my little index card that I'm using 5 milliliters. Okay, so now I'm going to plug in all these numbers that I've gotten into my equation. So I'm going to get 1 molar times V1, which is what we don't know, is equal to 0.25 molar times 5 milliliters. Okay, and I want to solve for V1, right? And so here, I'll walk us through the algebra. And again, I'm sorry I have to do this verbally. I know it's probably a little hard to follow along, but I'll post a picture of me writing out this problem along with this video. How about that? Okay, and so we're gonna just solve this. Okay, and if you have already solved it, then you can just wait and see what the answer is. Okay, but I'm gonna get, let's see, V1 is equal to, and let me pull out my calculator just to make sure that I'm doing this correctly. All right, so we got V1 is equal to 0.25 molar times 5 milliliters, and put all of that over 1m, okay? And so all I have to do is multiply 0.25 times 5, okay? And I should be getting V1 is equal to 1.25 milliliters, okay? And so 1.25 milliliters is how much of the stock solution we're going to want to use in this total of 5 milliliters, all right, in order to dilute it to the concentration that we want. Okay, so again, if that was confusing, no worries. I'm going to post, again, a picture of me kind of writing this out, and hopefully that'll help a little bit more. But that is how we would dilute solutions in the lab. And again, I know I'll be honest, it's not the most exciting stuff. But it is very important. It's a very important skill to have, and it's good to get good practice on it if you are ever interested in getting back into a lab after all of this is over. Okay, and so that's it for today. All right, hopefully it wasn't too bad. And do, again, leave me any feedback or questions or anything like that on the post, or I guess you can comment on the video itself if you'd like. All right. So I will see you next week during class, okay? And I hope you all are having a good week so far. All right, bye-bye.